Color Computer 3, Colors, Lesson 19, Part A. Get to talk a lot about palette registers and colors, which we've done before, but we're going to get into maybe some more detailed now. Okay, COCO 3 with 64 colors was a giant step forward from COCO 1 and 2, which you could get 4 colors. And in this lesson here, we're going to look at understanding what those colors are and how to use them. Okay, here's a screen I don't even know where it comes from. It was something I seen on the internet, and I said, that's a good looking screen to do my testing with for saving and restoring screens, capturing them, because it had lots of single pixels, and it also had some colors. So I take no credit for the screen. I downloaded it, put it on my Color Computer 3 emulator, and I wrote a capture program which compresses. I captured it and using it here. Also, I got this here. I had downloaded this rainbowy looking thing, okay, for good looking for a test. So I also captured it, run it through CoCOSC, and was able to compress it and restore it. And this is actually a screenshot off of the Color Computer that I cropped and put it in here. You notice from Color Computer 3, because if you look at the edges, they're not smooth because we don't have very many pixels. We got 620 as opposed to some of the stuff on the Mac and Windows have thousands of pixels across. So anyway, we'll look at how we did some of this. All right, we're going to go back through stuff that we went through before. We'll go through it again and see if we can get a clear understanding, either for if you're building a sprite or doing a background. First, we'll look at GIMP again, or we'll talk about GIMP, and then in part B, we'll actually build something in GIMP and save it down as a JPEG or a PNG file, okay, in your picture file. And also, or if you download a background picture from the internet, we'll have it in this file. Then will be copied into CoCOSC, where it will be basically converted to the correct color numbers for the palettes for the CoCo. And a lot of times you have to do a little bit of manual tweaking after here and to get it into the CoCo. Okay, and what we're going to talk about is RGB, red, green, blue. We're not going to do anything with composite. We're only going to do RGB. Excuse me. Okay, if you go on the internet and you search for RGB color wheel, you'll get hundreds, if not thousands, of examples. And I just picked this one here because it was kind of cool looking, but it didn't have thousands and thousands of colors. Okay, it's got our red at the top, our green here on the lower right, and our blue on the lower left. So that's our red, green, blue. Now, if you mix red and green together, you're going to get yellows right in between there. If you take a red and a little bit of green, you'll get orange. Okay, or now if you take green and blue, you'll get cayenne. Likewise, you take blue and red, you'll get magenta. Okay, that's how it works. It's got all these other hex codes in here, and we're going to get into them pretty heavy, okay, in the next few pages here. Oh, and I was looking for bar charts and that for colors. I seen this. I thought this was kind of interesting. Color names if you're a girl, and it's got some good ones in there. Grape, orchid, strawberry, bubblegum, salmon, tangerine, etc., etc. All kind of names you would have no idea what they are. But if you're a guy, you get red, purple, pink, orange, yellow, green, and blue. I thought that was kind of funny. I think it's kind of true also. Okay, we're going to look at the RGB color codes for Windows and Mac, for GIMP, CoCOSC, and COCO III. Okay, in theory, they all use the same codes. Okay, COCO III indirectly uses the same codes. CoCOSC will convert them codes into the 0 through 63 that we use, but in a sense, it's a derivative of what the other ones use. And they're usually displayed as three characters. The first one being the red, 255 can be in the, I'm sorry, be the red, green, and blue. Sometimes it's displayed with a pound sign, two hex characters for red, two for green, two for blue. Or you might see it as hex characters with dollar signs, red, green, blue. Or some variation of this here. There'll be three separate either decimal hex numbers together to put together the mixture of them, or the intensities of them, to give you different colors. Okay, I've got a list that I will provide in the lower, or you can download it. It's colorslist.txt. It's a text file that I do not recall where I got it from. I got it a long time ago, and it originally had on this left-hand column 0 through 63, which is the 64 colors available on the color computer, and it had the description, the black, all here. Okay, it didn't have dark blue. See over here with the asterisk net, if I changed the color to what I wanted to call it, I just copied it over here and give it the name I wanted to use. So I don't use all 63. I mean, they're all available, but mainly the ones that I possibly would use, I've noted over here. Okay, we'll get into what all, and then I added this column here, which is the hex value of this, because I mainly use hex colors like 17, but really is a hex 11. And I added what the red, green, blue characters are to make this color for the color computer. If you have the red, green, blue at 000, it relates back to 0. So if you want it black, you just have 3 zeros. Likewise, blue. We've got our red, green, blue here. So if you got FF, which is full intensity blue, okay, which is a 9, you put 9 in a palette register. And we're going to go through more of them. So the list is, all it is 0, like I said, 0 through 63, and all the names. Again, I don't know where I got the list from, but it's what I've been using for years. Okay, so let's look at some what, how this thing holds together. Okay, dark blue. Okay, which up here is number 1. Okay, and this screenshot here is a program that I wrote. It's called colors.basic, and I will also provide that on a disk for you. Okay, and you can step through all the colors. Okay, well, I've just picked out here this dark blue, which originally was called low intensity blue. Okay, it's 1, or it's also hex 1, and here's how the bits work out for red, green, blue. The first 2 bits are not used because we only have 64 colors, so that would be, and if you turn all the bits on, it would be 3F, or 63. Counting 0 would be 64. So dark blue is this one, kind of just, here's red, green, blue, red, green, blue. So if you turn just this bit on, which is 1, okay, you're going to get the lowest intensity of the blue color. It's hard to even tell that it's blue, so I call it dark blue. Okay, so now let's look at another blue, one of the blue ones. Okay, the one that I call dark blue. It was originally called medium intensity blue. To me, it was dark blue. And that is number 8, all right, or hex 8. Again, these aren't used. And we got this blue turned on and the other one was off. So that was our low intensity. This is medium intensity, and this is the color you get. Okay, next one, the one that I call blue, okay, which is 9, or hex 9. We got both the blue bits turned on. Okay, that's called full intensity blue. That's the 3 choices you get. You get one this blue, or both the blues. Now, if you want a different shade of blue, you've got to add some reds and greens in there somewhere to get other colors, which what I'm using and they use is this light blue, which is decimal 57 or hex 39. It's got our blue, low intensity, medium intensity, which are high intensity, and adds in the middle intensity, red and green, come up with this color. That was in the list the way it was, and I continue using it as light blue. Your eyes may be better with colors than mine, and you may want to change it to find a better color, but that's the ones I use. So that's how to, all it was is that's how this works, how this list works. Okay, I didn't go through all of them, but the program I will provide you, you can go through each one. Okay, here's some of the blue ones I picked out. And there's more things that have blue in them, but 1 was the dark blue, 8 was the dark blue, 9 was the regular, I call it regular blue. Then there's a green tint blue, cayenne blue, and light blue. And there's other ones that use the blue. Now, if you noticed all these, I'm gonna go back one step here. You notice in here, the only things we got in this list is 0, 55, AA, or FF. That's hex codes, okay? That's the only ones on the list. There is no 72, there is no 21, there is no 117, okay? We have just the 4, 00, hex 55, AA or FF, or in decimal 0, 85, 170, 255, and that's what they stand for in this list. And you'll see why they're used and how they're used in converting from outside sources through CoCOSC into color computer. Okay, here's the bottom of that list also. Okay, this is down through 63. And if you put full intensity and red, green, and blue, you're going to get the white color. Back off a little bit and you get the light yellow. And here was our light blue that we had for AA. That's, I'm sorry, AAFF is a light blue. And all the different, there's different colors there. So all 64 colors are in this list. Okay, back if you want to, and I'll put a link to these back in lesson 15, parts A through E. We did some palette animation. We're going to cover same material here, but maybe a little bit more detail than we did over there. We'll look at the GIMP and the CoCOSC. But here was the kind of colors that we used over there. We used the full intensity red, which was FF, R255, 000. Green, here's our red, here's our green, FF, and blue is 0000FF, and a light yellow, FFFFAA, and a light blue. And we also had with our background over there was this light gray, which is all A's. So again, lesson 15, look for the link in the description below and review. And here's the sprite we built over there. Okay, we had the light blue, the light yellow, the red, the blue, and the green, and they're repeated going up. And we played with them over there in lesson 15. So I just put that here. That's what we had done before. Okay, I grabbed another wheel chart to do a little more explanation. Okay, it's basically the same thing. We got our red here at the top, and it's got some hex FF0000. Okay, we got a green 00FF, and we got our blue over here. Right, this one has 24 colors, the other one had 12. Well, we don't have all this nice selection, remember, because all these different ones here, it has 80, 40, C0. Remember, we only can use, you can use whatever you want, but the CoCOSC only uses 55, AA, and FF. So an example here, if you brought something in from the outside or you designed something and you brought it in either through downloading or you built it and you were using lime, I just picked it because it was right here close, which is C0FF00. And you'll find out on any chart or any selection for colors on any system. Okay, well, C0 doesn't match up with anything in our chart, okay? So here's the closest ones to it is number 50 or 54. This is AAFF00, green tint yellow, and this one's FFFF00. The C0 falls in between both of them, and I've never seen the code, but CoCOSC, the best I can determine, it picks out the one closest to it, okay? C0 is closer to AA than it is FF, okay? There's quite a bit of difference in between them two. So it would select it and give you this, use this color here, which is this green tint yellow, which is this one right here. You would not get the lime, you get this one here, which is closer to yellow than the lime. So your separation of color would not be near as good as if you were using the true line. Okay, and I put this other one in here that we'll use later on. Okay, 23E247. You can put that in there, but CoCOSC is going to say that 23, it's closer to 0 than it is 55. E2 is close to FF, and 47 is close to 55, and we'll get some kind of a color out of that. We'll look at that. Okay, some examples here. Okay, I downloaded this Rubik's Cube on the left. Just out there, it was a PNG file, and probably come off some system that probably had, many thousands of pixels wide and high resolution, and probably 64 million color selections. So everything is crisp and clear. All the lines are nice and sharp. Okay, well, here's the one that's on the color computer. Now, it's not a replica of this because the one I downloaded, I don't know, 2-3 years ago was like this, but I didn't, for some reason, I didn't keep the original. I run it through CoCOSC, and it did a pretty good job on color selection as far as I'm concerned. But as you can see, the edges are rough because we don't have enough pixels on the edges to make them super smooth. But it did pretty good. And this is actually displayed on my Color Computer 3 emulator. And I just cut it out and pasted it in here. This bar down here, I don't have the slightest idea why it's in there. I think I put that in there when I was first testing different colors. And I think I put it in there and never deleted it, but it means nothing. There's another example. I downloaded this picture of a Pepsi can off the internet for a test. Okay, that's the original PNG file. It could have been a JPEG, but I don't recall. And I run it through CoCOSC, did a compression on it, and then brought it into Color Computer. And this is the actual picture. I did a screen capture on this of the Color Computer. It looks pretty darn good, but if you look at it close, okay, especially in this lid area, you'll see it's kind of dotted up where this one is a little more smooth. And the biggest place is right here in this red on the can. Okay, up here, it looks more like the sweating the can is doing with all this other red colors within that red. Down here, they're not in there. Same way in the blue. It's lost part of the blue and probably lost a lot down here in the grayish area. Now, why did it do that? Okay, well, if you don't have all the same colors that match that 55 AAFF, it's going to go to the closest one to it. And in some cases, it might have put it into the same color red. Other situation could be, remember, you only get 16 palettes or 16 colors. Well, I can guarantee in there with all these different shades of all this stuff, there's probably 30, 40 different colors in here. And I think what CoCOSC does is get something that's closest to the color that it's looking at, and it just fills it in with something that's close to it. But all in all, I say that's a pretty good Color Computer 3 image as opposed to something like that. Okay, what I do, and you don't have to, is what I suggest is if you're downloading something that's display like that, or for using your background, or you're building a background, limit it to about 12 colors max. It's up to you what you want to do. I keep 4 of them for sprites. I use 0 through 11 for the background and 12 through 15. You may say, wait a minute, I'm going to have 4 or 5 different sprites, so you may want to go 8 and 8, but you'll have to decide what you want to do with them 16 palettes. Okay, I'm going to provide you with that color list we looked at and a DISP 320 disk. It's going to have that color basic program that broke them out and showed you all the different hex bits. And on there, that program's on that disk. There's a program called Display or DISP 320 Basic, and an assembly language program, DISP 320 bin. It will display a bunch of them test images that I was just showing you. There's some test images, I don't know, 8 of them or so in there that are in H screen 2 mode, and 2 test programs, which we'll talk about here in just a little bit. Okay, let's look at the programs that are on that disk. I'm going to have to, I'll break this off and I'll do another video, and I'll paste these things together and get back to this one here. And that will be the end of part A. Part B, we'll really dig into GIMP, CoCOSC, and a program called ColorCop. And that should follow right close behind this one that we're doing here. And part C will come in the future to capture, restore, and display some 256 pixels instead of 3 pixels. So I'll break away and be back soon. Okay, we have a couple of things we want to test here. First one's a program called Colors, which I already have loaded again. And that's the program that we use. Let me demonstrate in the previous part of this lesson. We'll run it. Okay, sometimes when you run it at the very first time, you won't get the white background. Just hit Q, quit, and run it again, and it will come up with the white background. What this is doing is showing you each and every color, all 64 of them. Starts with 0, gives you the hex representation, and this is what you would be putting in the palette register if you wanted black. Okay, and how that breaks down is this is one byte here. The first 2 bits should always be 0, and everything else for black is zeros. You notice in here we have red, green, blue, and red, green, blue. That's for black. So down here it tells you if you want to step through this one time, up and down arrow, left and right will step 5. So I'll hit the up arrow. We'll go to 1. Okay, decimal 1 is also hex 1, and in this byte it says 00001, which is our 1. Okay, what that did is it's turned this one blue, this bit for blue. Okay, this is low intensity, and this blue is medium intensity. And if both of these are on, it's high intensity for the blue. Likewise, same thing with green and red. So dark blue is the name I give it, okay, is low intensity, which means it's darker. I'll step up one more with the dark green. You see the green low intensity one is on and the rest is off, which makes it 2. That's the 2-bit. And likewise for 3, 4, 5, and that's the way it goes. I'm going to hit the left arrow and jump up 5, then go down 1, go down 2. So we get here to 8 is our other blue one that we've talked about before. So blue is a hex, either is 8, okay, which this is the 8, shows the bit rate. Remember 1, 2, 4, 8. So this here is the medium intensity, which is dark blue. Now we'll go up one more to 9, which is what I call blue. In that list I had is called full intensity, which both of these bits are on, which is an 8-bit and a 1-bit, which is our 9. That's what it goes through, all the different colors. And as you step through there, you'll get what each color example of it and what the bits look like. I'll skip through with 5s. You can just see that you get all the different ones in there. So if you want to know what a color looks like or find a color, you can just go through here 1 at a time, 5 at a time. There's yellow. Okay, and you get all the way down to the last one, 63, which is a hex 3F, and that's all the bits are on. Okay, and they're in there. Okay, hopefully it's a useful tool. You can look at all the colors and know exactly how they're set, as opposed to writing a quick and dirty program every time you want to see a color. And we'll quit, and that's going to be for the colors. Now we'll go on with the other test. Okay, to continue on, we're going to test a few other programs that will be on the disk. First, we're going to run display 320. Just over the past years, playing with capturing screens, restoring screen, compressing screens, I've converted a lot of things for background off the internet and to use them as testing for my program. So I've all kinds of backgrounds that are useless, but at least it showed me how to use many colors. Okay, here's the program. It gives you some options to select some different backgrounds that I captured. Okay, let's let's hit it. Let's do a 6. Okay, so it's going to load that compressed file out there, and then it's going to tell me to execute it to display it. It loaded it out to pages 0, 0, 1, I believe, 0 and 1, and we can execute it to display, Q to quit, and restore the palette, and that means restore the palette to the way it is exactly right now. When you type exit, we'll restore it back to that. Z will exit, we'll keep the same palette as the image has. So let's execute it. Okay, and there's the screen. This is one that I captured when I wrote a capture program that when you display a screen or you find a screen you like, you can execute it and it will capture that screen and the palette information with it into a file that's compressed, and you can redisplay it. So that's what it does. I didn't create this screen. I don't know. I got it from somewhere off the internet. I seen it and I said, okay, because it's got a lot of single pixels and it had some color. So I did that. So I'm just going to hit Q to quit. So run the basic program again, and let's try 2. It's called scraps. Why scraps? I don't know. It just looked like it would be scraps once you do it. Okay, again, I could quit or I could execute it. And there's scraps. Okay, that'd be something very difficult, I believe, to do in a basic program. I don't know if you'd ever use it, but anyway, I found this just seen on the internet, and it seemed like something very good for testing all the pixels. But you can imagine anything that you would copy off the internet or something you would create with another basic program that had hundreds and hundreds and hundreds of lines of code. You could run that, save it, and then load it back in at some other time without having to run all that code again. So I'm just going to quit again. I'm going to run it one more time, and I'm going to pick one. It's called dice. This is a simple one for this test here. Okay, again, once we execute after that, it's Q to quit and restore the palette to exactly the way it is now, or Z to exit and keep the palette as it is in the image. So let's execute it. It's very simple because it only uses 2 colors. It's a black and white. Okay, so a tumbler with some dice. Okay, it could be anything that you could imagine that you build, a house or a scenery or whatever you could put together. Okay, so I'm going to exit with Z to keep the palette as the colors as the image has. Okay, and when you do that, sometimes your screen you get funny colors because the image uses different palettes than the regular things do. But now I'm going to run a program called test 6. Okay, test 6 is going to, let me back up here. Okay, when I exited that program that was displaying it, when I exited, that program is still out there in memory. If you remember all the different lessons we had where the image is out in blocks 30 through 33, well, the image stays out there until you clear it or reboot your machine. So that image is still out there. So this program here, test 6, all it did was say HScreen2. Okay, I'll show you here in a second. And then I was able to, if you look down at the bottom, I used the hprint command in BASIC to add to that image. And it could have been anything. I could have something out there, a sprite running around the screen, but just the idea that I was able to print something on that original screen. Now I'm going to hit Q to quit, and I'm going to list that program. Okay, very simple. Very first line, it says a poke, no clear screen. Okay, if you look down at the bottom 2 lines, one, if you do poke here, it would put a branch never, and when you do an HScreen2, it will not clear the screen for you. Or to restore that back to normal, you would put the branch subroutine. So whenever okay, it's out in memory, you say HScreen2, it uses whatever's out there. So that's why we did that, HScreen2. Give it our colors. We're going to use is 0 and 1 because I know what the palette looks like from the image. I didn't have to change anything, so I know that it's only using registers 0 and 1. And I print it on the screen, roll the dice, wait for you to enter something, and then restore it back to normal clear screen. Okay, that's all the program does. But you could have put that background out there and you write anything you want, hundreds of lines of codes to do sprites, whatever you want, with just this program right here. Okay, I'm going to go back and run, oops. I'm going to run 320 again just to start with that same one. Okay, I'm gonna do one again. That way I get rid of all the H print line that was under and add everything. We'll get back with a clean version of it again. Oops. Okay, execute. Okay, there we go, a clean copy of it. And this time I'm going to exit with Q. Okay, it's going to restore the screen back to where it was when we executed. Now the palettes that was used for that dice has been overwritten by going back to this normal one. So I'm going to run a program, which is test 7. Nope, I'm going to load it first, let you look at it. Okay, it kind of does the same thing. First line says don't clear the screen, but then we got this for I equals 0 to 15, read A and poke it. Okay, you got this data down here, and this is the palette that matches the image. And it's only got the two colors, 0 and 63. So it's simple. But if you had something that had lots of colors, you'd have to have them all in there. That way you can, but this has to match the same palette as your image does. Hopefully that's clear. So when I run it, okay, right now the palette is set for this normal text. So I run this and this will change the palette back to black and white, and it will print the same message in there, roll the dice. Okay, so that's two ways you can do this. One, you have to know the palette, and the other one, you do Z and keep the palette. And I think that, yeah, that will all be on the disk and all that there. So that's going to end our demonstration for this one here. So back to main programming. Okay, we're back. We just did look at all the various programs that are on the disk. That's going to be the end of this part. We got part B. All those things we talked about earlier about the GIMP and CoCOSC and color cop. We didn't talk about what we'll do color cop. To make this part A a little bit shorter, we'll do these in part B. So look for part B, and then some other time we'll do part C, and we'll do screen captures and restore and look at some other images. All right, that's it. That's the end. Thanks for watching.